Bree Pettis here with our second in a series of skill building workshops here. First we taught you how to solder, and next I'm here with Joe Grand, who is an inventor by day and hardware hacker by night, and he's going to teach us a little bit about multimeters. Now, Joe, every electrician, every hardware hacker, everybody I know basically has a multimeter. What is it?
A multimeter is basically what I like to say is the Swiss Army knife of electronics measurement tools. So it's basically a unit that will provide you with all sorts of different measurements. Most meters will provide you with a way to measure voltage, current, resistance, continuity, connection between 2 points, testing diodes, temperature. Those are the basic functions of a multimeter.
Wow, that's a lot of different things it can do.
It is. It's really cool. So you just have one unit and you can go anywhere you need in your lab and you have all those measurements. And they come in a few different types as well. We have a digital multimeter, which is what we're showing today, which effectively just digitally samples a signal and gives you measurements. You also have an analog type, which basically has a gauge, like a speedometer on a car, that will show you in an analog fashion what the device is measuring.
Now, I've heard that those can be kind of big, kind of like a ghetto blaster.
Yeah, they come in different shapes and sizes, and I've heard they can get pretty big.
All right. So, next thing we got to know is how do you use it?
Okay, so first what we're going to do is measure continuity, which is basically measuring a connection between 2 points to see if there's a contact there. And this is useful for probing a circuit board. We want to know how components are connected to each other, or if we're maybe testing a component to see if there's a short circuit, we can do that with the continuity test. So what we do is with our multimeter, we'll change our knob to the continuity test mode. And most meters, when you hit your two probes together, that's how you can tell you're in continuity mode, will beep. In my case, the meter will beep.
There it goes, it's beeping.
It's beeping. So that's how you know that there's a connection. Now, one thing to be aware of is this meter has an auto power off mode. So this turned off on me while I was trying to do this. So if you're sitting here probing a board and your meter turns off, you might not hear the beep. So be aware of that if you have a meter that does have that functionality.
So you could be actually working and going, oh, is this connected? I'm not hearing the beep. I'm not hearing the beep. But it right. Auto powered off.
Exactly.
Okay.
So what we'll do is we have our connection, and we'll just probe around on the circuit board and see if we can come up with any sorts of parts that are connected.
That one's connected?
That one's connected. What do you know? We can also just poke around and see what else. And you can take either probe, red or black. It doesn't matter. When you're testing continuity, you just want to see the connection is there.
Well, that is really cool, the way you can put those probes in different spots and see if things are connected.
It is. It's really useful for hardware hacking and just reverse engineering in general.
All right, so what's next?
Next, we're going to measure resistance with the multimeter.
Cool.
And with resistance, what we'll do in this example is measure the value of resistors, which are used to control the amount of current flowing through a system. They resist the flow of current.
So I need to know how much a resistor was resisting.
Yeah, you want to know the resistance value, which is in a unit called ohms. There are, if you look closely, some colored bars on a resistor. Either 4 bars, maybe 5 bars, and those colors are actually used to denote the value of the resistor.
Is that a secret code?
It is a secret code for engineers. And there is a resistor color code chart that you can look up the different values. So that's one way to just measure the ideal resistance of a resistor. But if you want to measure the real resistance, because just based on the way parts are manufactured and the different tolerances and variances of materials, nothing's ever ideal. So if you look and say, oh, I have a 47 kilo ohm resistor, you might get a 45.3, you might get a 47.2. So you want to measure the value of the resistor to see what you're actually working with.
Okay. So measuring resistance, it's just not futile.
Just not futile at all.
So if you can figure out what the resistance is with the color bands, why would you want to measure it?
Well, the color bands tell you what the ideal value of the resistor would be. So in the ideal world, but we don't live in an ideal world. The tolerances of parts, the variances in materials, sometimes you can only get close. And you'll see actually there's a gold band at the end, or sometimes it's silver, or other colors that denote the manufacturing tolerance of the part. In our case, in most projects that you're working on, you'll use a 5% tolerance, which means if you have a 100 ohm resistor, the actual value of that resistor might be 95 ohms, it might be 105 ohms. So you have this tolerance there. So being able to measure the actual resistance can be useful in a lot of ways.
Oh, cool. How do you do it?
So all we have to do is set our multimeter to the resistance mode. In my multimeter, I have a few different ranges. So I need to know the general range of the resistor before I actually measure it, and that's just a function of the multimeter. If I had a higher end multimeter I was using, it can automatically range, so you don't have to tell it 2000 ohm, or I want to measure something that's 200 ohm. It will automatically know. So in our case, even if you don't know, you can just cycle through until you see the value. Otherwise, if you're in too low a range and you try to measure the resistor, it just won't come up with the value.
It's just not showing anything.
So you just go to the next higher one. In our case, that's not going to be the right one. You go, in our case now, we set it to 20 kilo ohms. Hold down our probes right to the resistor.
9.78 kilo ohms, which is pretty close to 10 kilo ohms, which is what this is supposed to be. Now, I got another question for you. Let's say I've got a battery, and I want to know, is it still a good battery? Can I do that with this?
Right, sure you can. The multimeter provides you with a voltage measurement function. So all we have to do is take our probes, apply them to the two points on the battery that we want to measure. So what we also need to do, in my case, is set the multimeter to the correct DC measurement voltage range.
So you put it in 200 volts.
I put it at 200 volts, which in this case says we can measure anything below 200 volts.
Oh, okay.
And this will display it on the screen. So if we're at 2 volts, but we're trying to measure a 3 volt battery, we won't get the measurement on the screen.
So this is the maximum amount of voltage?
The maximum, right.
Okay.
And again, that's a function of the meter, and some meters will automatically set that range for you. So we take our probes. Typically, you'll put the black probe to the negative side of the battery, or the ground side of the battery. So we'll put our black probe at the negative, our red probe at the positive, and measure our voltage. In this case, 3.1 volts, and this is a 3 volt battery, so we're right there.
Right.
If you do happen to reverse the leads,
yes.
That's still okay. You won't damage the meter. You'll just see a negative voltage on the screen.
So because the positive and negatives are backwards, it's a negative 3 volts.
Right.
Is what it's measuring.
Current's flowing the other way, and it's okay.
Okay, cool. Okay, so now we can measure voltage. Is there anything else you can do with the multimeter?
Yeah, you can also measure current, which is important if you want to see how much current, how much power a circuit is drawing. Maybe if you're trying to match up your circuit with some documentation, if you know your circuit's only supposed to consume 20 milliamps of power, but for some reason it's acting strange and it's drawing 50 milliamps or 100 milliamps, you might be able to say, okay, something's going on there, something's wrong, it's not matching up. So that's an important one to do. With measuring current, you really need to be careful because the measuring system, instead of what we've been doing with continuity and resistance of measuring across a component, measuring current is done by basically inserting the multimeter through the system, into the system in series with everything else.
So rather than doing it in parallel, you have to hook it into the system so that it's in the system.
Right, so it's in the system and the current can flow through the meter and the meter can accurately measure it. So what we have to do in that case is with our probes, for most of the basic functions, the probe stays in one location on the multimeter. For current, there's a separate area, so you actually have to remove your probe and then put it into the milliamp section or the amperage setting. And what you hear is this thing's beeping at me right now. It's saying you're set in a DC voltage mode, but your probe is in the current measuring. So something's wrong.
It's upset with you right now.
It's upset with me. So I put it into the current mode. Beep goes away and we're ready to go. That's one way you can easily damage your multimeter is measuring voltage, trying to measure voltage when you're in a current measurement setting, or trying to measure current when you're in a voltage measurement setting. So you want to make sure your probes are aligned properly for whatever you're doing.
Do you have any recommendations for a multimeter that somebody could get?
Sure, there's all sorts of different types out there as we mentioned. What we're using in this demonstration is an X-Tech 410. And that's a pretty good entry-level multimeter that you can get from Contact East, or maybe some other companies as well, maybe for $30 to $40. You can also go to Radio Shack, pick some up there, Fry's Electronics. I have a Fluke model that I use in my lab at home, a Fluke 111 series. That's a little higher end.
Yeah, my brother was an electrician in the Coast Guard, and he's got a Fluke. He was like, Fluke.
They're really good, really rugged. Once you get to that point, getting a Fluke is the way to go.
Awesome. So now you've learned how to use a multimeter. Go dig one out of your toolbox or go get one.
Start measuring.